Circuit simulation is incredibly important when you're starting to deal with more complicated circuits. We can't build every circuit we want to test, so simulation is a really good way of testing a circuit without actually building it. In fact, it is the preferred breadboarding technique. If you are really good at simulating, you can save a lot of time and effort when you're trying to design a circuit. You can also use simulation to check for correct answers, but it's not a substitute for using the actual problem. It is generally just a way of making sure that you are doing the correct thing. If you don't understand how a simulator works and you don't understand the limitations of what you're doing, then you're not really engineering the problem. You need to know how models in circuits are designed, how, say, a voltage source or a diode or a transistor is actually designed, and also how to change them. If you want specific characteristics in a device, you need to know how to modify those. You also need to know how to control the simulator and make sure that it's doing the most accurate job. In some cases, you may be simulating something that has a transient part, and you need to eliminate that. Otherwise, your answers aren't accurate. So you need to get accuracy, not just what you want to get out of the circuit. You need to understand the theory behind a simulation if possible, so that it will be easier to understand the actual results you get. The initial SPICE circuit simulator was developed at Berkeley around 1970. It basically stands for Simulation Program with Integrated Circuit Emphasis. There are many versions of simulators around now. The textbook that we use right now emphasizes PSpice, which we used to also in this department emphasize quite a bit, as well as Electronic Workbench, but LT-SPICE by Linear Technology is actually where we are going in this department and really what we use now. It pretty much doesn't matter what technique you use, except for, of course, if you are required to use one, you need to. But if you have experience with several simulators, it actually gives you a better understanding of the advantages and disadvantages of any of those. So the first and most common version that is used is PSpice. That was the industry standard for quite a long time, still is. When I was in graduate school, all of my circuits were simulated in PSpice. It's quite old, started out as a DOS version. It's pretty good at doing analog and digital simulation. However, we only have the evaluation version here. So the component libraries are limited, and it can be buggy. If you have used PSpice before, you will understand that this is true, that you can set up a circuit and it just doesn't work right and it kind of all locks up and you have to start over. But there is a version of PSpice on the Cube building computers and also the lab computers. You can also put the evaluation version on your computer, even though you can't add to the libraries. The circuit size is limited. It can't control how the simulator works, and most importantly, it doesn't run on a Mac. And if you're like me and you have a Mac, where you're kind of stuck then. So PSpice is not a good choice unless you have a PC available. Electronic Workbench is another version. We actually have the commercial version on lab computers and in the Q building. It does well with analog and digital simulation. It integrates with LabVIEW if you happen to be using that. However, I don't know if you can access it off campus. There is a not free student version that's pretty good, but I also don't know if you can add to libraries if you need to. As you can tell, Electronic Workbench is not my simulator of choice. I have extensive experience with PSpice, and then I also have extensive experience with the last version, which is LT-SPICE. This particular simulator was designed by Linear Technology and is actually really good. It's mostly analog, so for engineering electronics, it works really well. So there are all kinds of components that are included. So any linear technology, op amps, power supply controllers, anything like that. And it's easy to add component models. You can control how the simulator works. There is no circuit size limitation. It's free, and there's a Mac version. And the Mac version actually runs reasonably well. So unlike some situations where the Mac version is significantly worse than the PC version, this is not the case. It is different, and there are some differences in how you control the Mac version, but it works reasonably well. So in this class, we will use LT Spice. We switched as a department about a year ago to introducing LT Spice in circuit analysis. So if you took circuit analysis recently, you will have familiarity with this program. Otherwise, you will have used PSpice, and you will find that LT Spice is less buggy and is just as useful as PSpice. So simulations are important. We do quite a number of them in here, and it is good to know the advantages and disadvantages to each type of simulator.